Hi everyone, in this video we're going to create a voice assistant in JavaScript with Tensorflow that can do something like this. Hello.
Hello Ilum, how are you doing today?
How's the weather?
Good morning Ilum, hope you slept well. For today's schedule you have a meeting at 10 a.m. with your manager.
Weather please.
The weather for today in London is 11 degrees.
And there you go.
Hello Ilum, how are you doing today?
Absolutely fine, and it does a really good job with listening voice and just getting back to you through the browser speech API, so it can directly talk to you once you give it commands. Just like in this case, we worked with the weather, so it goes into a weather API, grabs the weather for the city, and it just gets back to you with a response of what's the weather. Or you can, for example, say good morning, and it gives you your today's schedule. Just everything working here in real time on the browser using the help of Tensorflow and the speech models, machine learning model, of course, and of course using our beloved JavaScript. So all of that is being done in the browser, and it's like a project of mine. I didn't want to share it with you guys. So hope you guys have enjoyed it. And without further ado, without further say, let's just jump into it. So let's get started and install the actual required dependencies for creating the voice assistant. So as I said before, we are going to be using TensorFlow. So you have to install the TensorFlow JavaScript adapter for working with TensorFlow and being able to control or use the TensorFlow models using JavaScript. I'm also going to create or use the speech command model, which is like a machine learning model that allows us to recognize words like from a microphone and transfer it into like a text, so it can clearly understand it uses the natural language processing or the NLP from like specific neural networks, and it just allows you to like recognize words. So we're going to be using that as well, alongside a couple of other packages that allows us to visualize the audio. So since we're going to be using a voice assistant, so we're going to be using like some like specific and cool waveform of like visualizing sound. So we have like once we talk, we get these bars, downs and ups, so to visualize the sound. And therefore we're going to also be using the wave visualizer package for doing so. So let's go and install this real quick. I'm using Yarn as I said before, and for the project you're pretty much looking right here. I've already set it up. I've created most of only the boilerplate thing, not the actual logic or the application logic. I've created like the Webpack configuration going to be needed. Also, let me just get rid of that. So this Webpack configuration is going to do everything you need for working with like the AI in here, because working with AI models and like machine learning models right here with TensorFlow, tensors, it's quite hectic. So you have to get into your own Webpack configuration in order to use like ES6 and ES9 features alongside the neural network or the models. And alongside all of that, I've already created a boilerplate like the HTML file. I created some CSS and also some HTML file boilerplates created in here. So I'm going to go through this in a second after creating or installing the dependencies. So as I said before, we're going to be needing in here is actually the TensorFlow model, or just like the TFS.js. I'm just going to install like TensorFlow /TFJS, which is TensorFlow for JavaScript. It's an adapter. And also you're going to need to pretty much add, I think it's TensorFlow models. So it's TensorFlow-models speech. Okay, so it's a namespace. So speech commands. And there you go. I'm also going to be installing Wave Visualizer. So this one allows us to actually, as I said before, visualize the actual sound, and that's it. So that's basically all what we need in here. Make sure to install it as a required dependencies, because we've got other like dev dependencies we need to install. So as to take a look on the bank.json, we got a couple of them like Webpack and stuff like that. So I already did that. So you can grab the projects from GitHub and you can start working with it right out of the bat. Now let's try to pretty much let me walk you through this index.html. So here including a couple of the Up.js bundle that's going to be bundled by Webpack. Also got some Roboto fonts from Google Fonts. And here we've got a couple of things like the title, voice assistant, and some buttons, and also some IDs, and a canvas is going to be used to draw the visualizer bars for our sound, and also we got a couple of other containers. It's pretty basic index HTML. I'm going to explain it even more once we go through the code and try to work with it. And I said before, I already worked this, so I created the style as well to make everything look the way that it is. So that's basically the projects. You can grab it from pretty much the GitHub repository you're going to find down in the description, download it, and you can get started with it really easily. Now, let's jump into the most important part among all of these, actually how to generate the model. Now, when it comes to machine learning, for actually working with machine learning, you have to make the machine learn. And how you make actually a machine learn is actually by feeding it by a real world data. So for example, right now here, we're going to be creating a voice assistant. So for a voice assistant, we're going to be needing is actually a human voice, like human direct commands. For example, you tell the voice assistant to grab me, like, how's the weather? Or you say good morning, and you expect from the voice assistant to tell you some news, or just like say good morning Islam or something like that with your name. Or you pretty much expect it to ask it about a specific option. It just goes and searches Google for you or something like that. So this specific or direct speech commands are recognized by an NLP, which is a natural language processing neural network. And this neural network is how it's being trained is actually by feeding it a lot of voices from a different kind of peoples, like different ages, and like it gives them like different voices and you know, like all the stuff about sound, and you just provide them with specific data about that, and it just like keeps trained over and over all over this like kind of data in order to exactly know how to recognize this pretty much words that are said, and it just like convert them into a text, and it can use them for like web searches and so on and so forth. So using this platform, which is super great, made by Google, of course, some great people, some developers behind Google there. So it allows you to pretty much train your own pretty much models using your own data through the browser. How simple is that? People just create large Python projects in order to do that, and you can just here access it right through your browser, and it has fully support of JavaScript. So as classic there is three different type of models, like object detection or image object detection, there's pose detection, and audio project. So this audio project is going to be using it for detecting or recognizing the voice, and this is exactly what I'm going to be using. So just select this, and it's just going to jump you into this really simple interface. Now let's jump into this interface. So this here first, the background noise, and here you have, it's mandatory or required. You have to record 20 seconds of background noise, so the model you're going to be training knows exactly like to separate between when you talk and when you don't. So it just like sits there without like no talking, no speeches, so it knows it directly that this is a background noise. And here you can add as many classes as you want. So the more classes, and each class can represent a specific word to like, I don't know, a couple of words, because this one is quite limited. So you can't tell like a really long sentence and you expect it to just like process all these sentences. It has like a limited processing capabilities, but you can just like allow it to process like more than 3 or 4 words, and you can do that really easily. So all we need is just like keywords, like you say weather, or you say good morning, or you say hello, or you say, I don't know, something like that, just like some specific keywords. And you can add as many classes as you want for the keywords you want your voice assistant to be able to recognize too. So for example, here I'm going to name this like hello and get started with it. And here I'm going to use the microphone. So this microphone is to record real world data that is going to be used to train the model. So you switch your microphone, I'm going to use my microphone here, and it can start recording. Like you can pretty much change the settings, how much like you can record. So the more duration you give it in here, the better the algorithm becomes and the better model gets trained. So you can choose, I chose in here like 30 seconds for all the models I've trained to get like more predictions or more accurate predictions, but you can choose as many as you want. So let's choose in here, for example, just demo settings. I'm going to use 10 seconds, start recording, and you can say hello, hi, hi, hey, hello, hi, hi, hello, hello, hi, hi. So as previously in here, what I did is pretty much I feed it with my own voice in a different manners. I say like high speeches like hi, and I say like low speeches like hello, and different stuff. So it can clearly recognize when I say hello, when I say hi. So it all like becomes on the class of hello. And make sure to rename your classes in here, because this is going to be used later on our code to pretty much know what is being recognized or what is being spoken at our microphone. So here's actually the sample. If you can pretty much go ahead and listen to this, and you can just preview it, or you can go ahead and extract the sample if it's all good. So here it's gonna just like extract them into like 1 to 2 second samples each. So it tries to get as best as it could from all the samples in here. So all the clears in here to waveform, so it gets all the sound in here, and like 10 audio samples since 10 seconds. So we got like each second, obviously, and you can train in here. And you can of course add model classes, like you say here good morning, and you can go in and add or record the microphone for this, like you saying good morning, like you say good morning or good morning or good morning, like different states you talking, so it can better give it a chance to recognize your voice later on once you generate or train the model. And here, for example, I can say how's the weather or something, and of course, yeah, you can do the same thing. You can talk to the microphone, or you can even upload your own audio from your like local device. And here for the background voice is actually mandatory. All you need to do is just like choose the microphone, hit record, do not talk. And that is it. I didn't actually complete it, but you don't need to talk for this. Like 20 seconds, and just like give it the normal background noise you have for like, you know, training the data, and hallelujah, everything will be great. After this, you can extract the samples in here. You have to get 20 in here. After extracting all the samples, having all the classes in here, what you can do, go ahead and train your model. You can go to the advanced section, and here for the advanced section, we got epochs. So what I mean by epochs, for those of you who knows, or like, you know, has a decent knowledge about epochs and how machine learning actually works, it's pretty much basically a for loop. So how many times you want your data to be fed and trained. So like, for example, this is actually the data going to be fed into the neural network in order to generate the model. So this is actually represents the I for the for loop. So you can give it 50, but the more you give it, the better it becomes. So the better it gets trained. Like you give it like 300 in here, it's going to way much better than giving it 100. So choose as higher number as you could. Do not go like for a ridiculously high number, because this is going to just like break your browser, and it's going to take forever to complete. But just go for a reasonable one, like 300, 200. I personally chose 200. It makes really good, and just like, you know, does it really great. After finishing that, making sure all your classes, you can hit train. I can't hit train in here because I haven't, you know, completed all of that. And your model is going to be trained, and you can just like click on export your model, and you can get pretty much all the information how to export your model. You can even export it on Tensorflow Lite, which is or actually works on mobiles. And yeah, hallelujah. Here's actually how you can go ahead and include this or make this work on the browser using JavaScript. And that's exactly what we're going to be doing. Now, how you can get or access your models, you can just download my model, and your model is going to be downloaded in a zip file. It has like a JSON file, and it has a bin file that allows you to just like, you know, it's your own model neural network. So just don't manipulate this. Just keep it as it is, and everything should be going all good. So that's basically it, and that's how you can pretty much train your own models, and that's what I did. So I'm not going to be just going and training it here. I already created the projects for it. So this is actually the projects I got, and it's pretty basic, as I said. Like has background noise, has good morning, weather, has hello, and play me a song. For example, you can tell Google sing me a song or play me a song, and it just like start singing you a song, basically like a Christmas song or something. And that is it. So I chose 200 and I trained the model, and yeah, pretty simple. So after exporting the model here, I got it everything as zip file and I extracted it. So yeah, pretty awesome, and everything should be working absolutely fine right now. So all I need to do, I'm just going to close this, go back into our code, and for the models, I've put them inside of like the AI models folder and /voice model. And this is all of that models. So you see here we've got JSON files with specific data and some metadata for just like speech recognition, and we got the wait spin in here. Just make sure to keep them all there, and you can get started. As I said before, for the Webpack configuration, it like treats all of these and it just like handles them properly. So make sure to get this Webpack configuration. If you try to like, I don't know, create different projects, your custom project of your own, make sure to take a look on this Webpack configuration, because it's going to help you a lot transpile and work or just like bundle these AI models files, because it's quite mandatory. So yeah, basically that it is, and let's just go and get started working with right off the bat. Now for some scripts in here, I've actually included some start dev script, and we got Webpack CLI, so let's start Webpack development server. So let's go and do that real quick. Just gonna start, where is that? There you go. So just start a simple development server for Webpack. That's gonna watch our files and it's like auto reload or hot reload our files once we change them. And that's basically what it is. Now we've got the app.js in here, and it's being included inside of the index.js. So this is the main application file, and we're going to be using some like module JavaScript, only vanilla JavaScript, nothing more suspicious as far as I said, and just vanilla JavaScript on the browser, and everything is going to be doing inside of that. So let me close this, and all the code actually going to go to the app.js. And for this sake, I'm going to create a new file. So right now, what I'm going to be doing is actually going to try to use our microphone. Right now, the microphone, the same actually I'm talking through, is I'm going to use this microphone. I'm going to create a visualizer on our browser that visualize the waveform of the sound that comes from the microphone. Like, the bars when you try to talk. This is what I mean by a waveform of a sound. So yeah, I'm going to be creating a class that takes that and just like manipulates it. So I'm going to do like voice visualizer.js, and this is basically going to be the class. I'm going to do like export default class voice visualizer, and there you go. So this is basically the class that I'm going to be using. I'm going to have some constructor in here, just some constructor that does absolutely nothing, of course. And also make sure to include pretty much and go and import the audio visualizer library that we've got. So I'm just going to name this wave and import it from wave visualizer. And by the way, make sure to install this like wave visualizer, because I found all the libraries which are quite original, but they don't do the job. It doesn't work with me for some reason. So I figured it out, and I found this wave visualizer kind of clone of it, and it works absolutely fine. So make sure to grab this, because I'm pretty sure this one works and the others don't. So yeah, make sure to install this one, not the others. So let's create a function. I'm going to use an async function here, using with promises. And this one is actually going to open audio stream. So this is actually going to do the audio stream opening for us. And what I mean by opening an audio stream, I'm missing an E in here. So it opens actually the stream that allows us to talk through the microphone into the browser and grab this stream. So, and we're going to be using the Navigator API. So what I'm going to be doing in here, I'm going to just like call Navigator, which is a browser API currently supported by Chrome, fully supported as well with Firefox and many others. So you can take a look on the support of like the media stream API in the browsers. So here I'm going to use like media devices and get user media. So this get user media function is going to open up the stream for us. It takes an object, like what stream you want. I'm going to be needing an audio, true, but video, no, I don't need a video. So I'll just not say false, just like keep it as it is, and it should do the job for you. So this one is going to open up a media stream for you, and basically this is going to just like return a promise. I'm going to use try catch, since I use an async function in here. So using try catch and making it look like synchronous is the best way to handle that. An error, so I'm just going to open up an error, connotes open audio stream, and we can go and just print out the error. I would better just put console error in here. And for this one, I'm just gonna like do a wait. I'm just gonna do audio stream. And make sure to put the audio stream on the actual class. Just do like this, the audio stream, and await, and this should do the job for us. That's clearly seen it. It returns a promise of the actual media stream, and that should do basically the job for us. Now let's create another function. This function is actually start visualization, so it allows us to start the visualization of the browser and using the stream we opened. So I'm gonna call this like start visualization. So for this one, we're gonna just first open up the audio stream. Because this is gonna be like something like a private function or private method, so it better be called right here. So I'm gonna do await this open audio stream. This will open up the audio stream. It's gonna give us this audio stream or audio stream of a class. Then afterwards, what we can do is pretty much use this one. I'm gonna first initialize the wave. So I'm gonna do wave equals new wave. So this one is gonna create an instance of the wave visualizer. Now from the wave, what we can do is actually dots, and we can do from we have like from elements. So from stream, and this gives us like we give it a stream, and of course we're going to give it the audio stream, and here it takes the canvas ID. So this library here uses like a canvas API or the web canvas API to pretty much draw this bars and the wave form of the audio. So I already created that on the index.html scripts in here. I've got canvas with an ID output, and I just like give it some basic width and height. So all we need is actually the ID. Going back in here, just supplying it with the ID. And here for the objects, I'm going to give it like a type. Well, let's see. I'm going to use bars for the type. And for the colors, well, basically, let me see what the colors. It takes an array of colors, and you can give it like, you know, a type of specific colors for this particular one. So we can use that, both of these colors right here. And also we can give it a stroke value. So this stroke value, I'm going to give it 1 for like the width of these bars. And yeah, so this is the wave from stream. It's going to create from the stream, you're going to visualize this and output it into the actual canvas, and that should do the job perfectly for us. So yeah, there you go. We've got the function in here. Now the other function we need actually stopping the visualization, because we're going to have like a button that allows us to power on and shut down the voice assistants. So you have to allow it to actually stop visualization once we click this button. So I'm going to do like stop visualization, and yeah, for this one, all I'm going to basically be doing is actually loop through the audio tags. I'm going to do like audio stream get tracks, and this one is going to like return a media stream track, and I'm going to go through each track and stop this track manually. So I'm going to use for each. I'm going to go track track dot stop. That's basically what it is, because it opens like many tracks. You could be like using many tracks or like streaming through many tracks, and the proper way to stop all these tracks actually go for each and stop each one of them to properly stop all of these. And yeah, voila, so we got all of these, and we don't need an async function whatsoever. So that's basically it for the visualization, and we can just go ahead and get started and work with the visualization right out of the bat. Now here we got the visualization class. Let me jump back into the app.js and where all the magic happens. Now we have to use this class in order to create visualization as we talk through. So let me just gonna like index.html. We got a couple of things. So this is actually the button that allows us to, like, it's called the start button, that allows us to start listening or stop listening. So we're gonna be using this button right here. I'm gonna just copy the ID of the button, and this is gonna be the main button right over here. So I'm just gonna first import voice visualizer from voice visualizer, and here I'm gonna just like do button or like start button equals documents. I'm gonna of course use the vanilla JavaScript as I said before. So get elements by ID. Okay, so elements by ID in here, I'm gonna supply it the ID of the start button, and this should give us the start button. Now what we want is actually a listing for the start button click. Once we click on the button should pretty much start the actual visualization. So this is going to be all a stop button. So once we start the visualization, I'm going to just like toggle between the states and change the actual title or pretty much the text of this button to stop. So it becomes like more a toggle button between start and stop, and you got the point. So here we got start button. I'm going to just like on click. Okay, so it's gonna take just a normal anonymous function and just gonna be checking. So I'm gonna create another boolean variable. Just gonna make it this is started, and this is gonna be called false. Okay, so this is gonna tell if it is started. So if it is not started, this allows us to start. Otherwise, we're gonna allow us to stop. Okay, so start assistance, and here stop assistance. Super cool. And this should be more like a lowercase thingy. Nevertheless, so here we got the is started. So to check or to get started with this, I'm gonna create well, first I'm gonna create the actual instance of the voice visualizer class outside of the module. And for those of you who might be asking like why we are doing this way, why like because you know that creating global variables is quite bad. Why here we're creating global variables? No, we are not, because we're using ES6 module scope, and this is all being just put inside of this module, the app.js module, not outside, not shared on the window, not shared on the whole scope of the browser, nothing like that, because this is a module scoped like throughout the ES6 version, as you all know it. So this only stays on the module, which is like stays on a function scope, which is great, and it works absolutely fine. Yeah, let's just jump back in here. I'm gonna create const voice visualizer, and I'm gonna create an instance, a new voice visualizer. So there you go. Now here we can use the voice visualizer we created, and we can just go ahead and do start visualization. Super simple, and make sure to do await. And here let's apply an async function, because yeah, we need to await for this, otherwise it won't work. Now after starting the visualization, or just like before starting it, what I'm going to be doing is actually toggle the text, so it becomes like more loading text, and just like, you know, telling the user that, oh, we are starting the assistance, so you have to sit back and hold tight. So I'm going to do like start button, inner text, I can just make it become like starting, and there you go. Now after starting the visualization here, well, everything should be working absolutely fine, and it should say is started equals true. Okay, just make sure to toggle is started to become true. Now on the other hand, if you want to stop it, we can do like start button dot inner text equals stopping, and we don't have to wait for it, but sometimes we do. So we can do an stop visualization, and you can make stop button dot inner text start listening. Okay, so if you take a look on the HTML here, we got like start listening. I can make like start assistant, which it's a little bit better for the user experience or for the context we're doing in here. So I'm just gonna make here start assistance, and here after is started set to true, I'm also gonna do start button dot inner text. I'm gonna stop assistance because it's already started, so you have to toggle it. You know, basic toggling, and really simple. And just make sure to set is started to false because it stopped. And yeah, let me just put that right here, and it should absolutely do the job. Now if you go back, I opened this actually on port 3000 by default. So if I go back to localhost 3000, there you go, we got voice assistant, start assistant. If you click on that, so you see just like, there you go, we got the waveform pretty much. And as I'm talking through the microphone, so you see the waveform changes and just like absolutely work as we want it. If I just like, you know, go silence, there you go, it stops. So just like, you know, Indeed is pretty much working absolutely fine, and it does absolutely much better job. So I only added this for user experience. It's not that much of a beneficial thing. It doesn't do anything about actually a neural network or like voice recognition or something. Just it looks better, and it makes it feel more as a voice assistant itself. So that looks absolutely amazing. And let's just jump right now. I click exclusive, it clicks stop, immediately stops, and it just doesn't work as I talk. Click start again, and it starts all over the way again. Stop and starts. so you can toggle between the states in here, and it looks absolutely amazing. So here as well, you can tell if the microphone is being used by the browser or not. So just like a little debugging trick if that didn't work for you at some point, but it should do absolutely amazing job as I said before here. Now let's just go back or pretty much go back into the VS Code tab in here, and after finishing the voice visualizer class, now let's create the main important class, actually the voice assistant class, as it allows us to recognize words, and just like depending on this particular words that we recognized, we can just take actions. For example, we say good morning, and then we can use the browser like speech API to say to the user, for example, oh, good morning Islam, how are you doing today? Hope you're doing fine, or something like that. You know, voice assistant things that's, you know, we've all worked with Google Assistant and Alexa, so you should probably have a basic knowledge of how things works there. So voice assistants.javascript, there you go. And for this one, I'm going to export default again, class voice assistants. There you go. Now you got a constructor, pretty simple. And here I'm going to be creating something like two asynchronous functions. First one is going to allow us to build the model, because every single time on the browser we have to take this model and actually build the model in order to be able to use with TensorFlow, obviously. So I'm just going to name this build model, and the other one is going to be like init. So this is actually the initialization function, but what I would better call is actually start assistance, okay? Because it looks way much better than initialization. So it's the same thing, initialization or start assistance, but that should do a better job, obviously. So we will be needing actually the TensorFlow and the speech commands module we have actually installed before. So let's import all as, make sure to do all as, otherwise it won't work with you. So all as tf for TensorFlow from @TensorFlow tfs.js, and as well go ahead and import the speech command module. So where is that? I always forget what is the asterisk. So yeah, here speech commands from @TensorFlow modules speech commands, and there you go. So here we got the speech commands and everything. Also, the other thing we need to import is pretty much our module. As I said before, I've put the module inside like voice model folder, and this is all the data concerning that particular model. So make sure to go ahead and import both the model.json and the metadata. So for doing so, I'm just going to use import statements in here. And yeah, again, as I said before, I'm using this import statements right here, and you can use it freely because I already configured Webpack to pretty much tell that if I'm actually going to be using JSON, it just uses the file loader to do so, and it returns a URL for the file. Also, if I am as well working with the bin files, it's going to automatically be copied into the build folder. It's clear in here for us once we build it, and it's going to be automatically copied for us. So this is the proper configuration to work with, and make sure to get this configuration in order to be able to work with it. And here I'm going to do like so voice model from AI models voice model, okay, and so voice model metadata. I'm just going to copy again, AI models, voice model, and metadata. Here it's already forgot about including the actual model.json, otherwise it won't work with you. And voila! So here actually the model and the metadata we need to actually build the recognizer that allows us to listen and recognize for particular words. Now let's build this recognizer. I'm going to call recognizer const equals await. I'm going to use speech commands, and this one I'm going to use the create method. So the create method is going to take you know, the TensorFlow, the model, the metadata, and it's going to create for us this TensorFlow. And here make sure to use the browser FFT, not the software FFT, because it's not currently supported. And this one is going to allow us pretty much just like it uses the browser API to read through the audio stream and as well recognize it using the browser API. So here of the vocabulary, Sorry about that, obviously. I'm going to be just putting it in define because there's no limited set of vocabulary. And here, custom model artifacts or URL. So here for this one, we need to provide the actual model. So I'm just going to do voice model. And the other one, of course, I'm going to provide the voice model metadata. And there you go. This one, if you take a look on it, it pretty much returns a speech commands recognizer right at the bat in here. I think we don't need an await for that because it's synchronous and it happens synchronously. So we don't need to make sure that there. And here we need to call the actual functions. We're going to do await recognizer and ensure model loaded. This function or this method allows us to ensure that all the model data, the bin files and everything are being loaded through a secure layer, HTTPS, and everything being loaded fine. And there you go. And by the way, as I've told before, you can actually load this data, all this model data from the actual Google storage. So if you chose to store your models on the cloud using Google, you only need to do just copy the URL, put it in here instead of like putting the voice model here. You need to put the voice model URL, public URL, and everything will be working the same thing in here without any issues. Now the last thing in here, just go in and return the recognizer we built, and voila. So super cool. Now let's start the assistance in here, and first things first, we need to await for this .build model, and this one is going to return the recognizer. So make sure just do const recognizer and grab the recognizer, of course. And of course, you can pretty much go and do this .recognizer without waiting for this to be put right here or something. But I think using this API, it's quite better, and it shouldn't do that much of job. Or headless things actually. Now, since we got the recognizer, what we need, this recognizer gonna allows us to listen for specific commands throughout the voice, of course, and for each command actually listened to and processed and everything, you're gonna get a callback throughout the listen method. This callback is gonna have like the scores of the different classes we have used, because as I said before, if you take a look, I think I got rid of it. But if you take a look before on the Teachable website, once we created classes, so each class can have a specific score rounded from 0 to 1, and depending on that score, like the higher the score is, the what class it like belongs to. So for example, we get an array of scores, and for this array of scores, what we got is pretty much like you get like 0.5 and 0.2 and you get 0.8. Obviously for the 0.8 score, when you take a look on that particular class of the score, is the one being recognized the most. So it's like, a score system that gives you this numeric values to know which class is, the word currently being recognized or processed belongs to. So that's basically what it is. I'm going to use recognizer here. I'm going to use the listen method, and listen method, as I said before, it takes a callback, and so this one is going to have a result object, and the second thing it takes is actually the options. So introducing a streaming recognition config. Now let's go and improve the options in here. I'm going to use the constructor, do this options. I'm going to put the options right in here. So we're going to have something like include spectrogram. And this one is gonna, a specific option for TensorFlow to know how, pretty much either to include the spectrogram, which is like an array of floats of 32 bits that'll, represent the actual scores. So for this one, of course, we're gonna be needing the spectrogram. Also, we're gonna have like an overlap factor, so overlapping between different scores. And this usually goes between 0.5 and 0.75. So I'm just going to usually keep it 0.5 in here. Also, what we're going to be needing is basically invoke callback. So invoke callback on, what is this? So noise or and known. And for this one, I'm just going to say false. What it means, either if we invoke this callback, this listing callback, when the voice is like on the background noise, or when it's not recognized at all. So you better keep it false, because you don't want just like accidentally to call the callback and just like increase the over processing, thingy. So just like keep it as it is. It will do a better job this way. And the last one here is actually the probability threshold. So probability threshold, and for this you need something like 7.5. It's like a threshold, which is the maximum value that goes with it. So yeah, that should pretty much do the job. And this is all the options we need. Now back in here, let's feed these options. I'm gonna do list.options, and voila. So that's all we need. Now this callback is gonna be invoked every single time the recognizer hears a word and recognize it, of course, and process it successfully. So just gonna like call this callback with the result. With the results in here has all the scores that you need. Of course, you can do like const scores equals results dot scores, and this scores, as I said before, is like a float. As clear as in here, a float of 32 array, and each one, or like each member of this array is pretty much a score representing the classes and ordered by the same order you created the classes on the teachable website. So yeah, there basically is. Let's go ahead and console log this just to take a look on how things working. I'm gonna do like scores and scores, and here I'm missing an S. I know. Yeah, there you go. So we got things working here. Let's jump back into the object.js. Now once we start visualization, or just right before starting visualization, I'm gonna be starting. So I'm gonna do a wait. I'm gonna create first a class instance. So voice assistant equals a new voice assistant, and it should be by default imported for us. There you go. Cool. Let's copy this real quick. Dot start assistant. Right. Okay, super cool. And also I need to stop the assistant, so I am going to be using this right here. I'm going to do async stop assistant, and I think throughout the recognizer we can stop the assistant. So let me just think. Seriously, stop listening. So what I need to do in here is actually hold this into the class context. I'm just sure to do this dot. I'm going to do this dot recognizer, and it should do a better job for building out this. Okay, now we can use this dot recognizer dot stop listening, and this one is a promise, so make sure to do a wait for it. And yeah, there you go. So this one should stop listening, and we can just go ahead and start or use it right here, but we have to use a wait. So voice assistant stop assistant. Yeah, there you go. So we got things working right now, and yeah, as you see, it's compiling. It might take quite some time, and the bundle might be a little bit more than it is, because now it had got actually a huge object of the TensorFlow. So this TensorFlow is being all bundled, as well as the peach commands with the models files and everything. So the module here might become a little bit hectic, and later on for like production ready service or production ready solution in here, what you need is actually host your models in a separate server, then load them once you need them through HTTP or HTTPS. So yeah, you got the points in here. So let me just go ahead and open up or inspect this real quick. We got the console. Now if I click start assistant, we get the waveform, and there you go. Now we got the scores. As we talk, we got a different scores. As clearly said before, the scores are an array of like numbers going from 0 to 1, and it's telling you the score of like what class. Now let's try to go ahead and grab the class, or know exactly the word we are talking through, using the classes, of course. So for this one, I'm going to do like class labels, and this one is going to allow us to get the labels or the classes we have created on the teachable machine, like the class names like hello and good morning and everything. So I can use the recognizer. I can do this recognizer dot or word labels, and this one is going to allow us to get the word labels string array really easily. Now how we can tell if what is the class that has the highest score, in order to know that which class is being spoken. Of course, it depends on the scoring system, and you have to know the high score in order to know the currently spoken, you know, on the predictive neural network. You know, of course, you got the point. So yeah, let's go ahead and use the reduce method in here. So we got class labels real quick in here. Here, what I'm going to be doing, the const word score, and I'm going to use scores dot. Well, that actually is out of the so that actually is out of the result, and make sure to use it right here. So I'm gonna do word scores before. So scores, I'm gonna use the reduce method, and this one is gonna allow me to get the previous value and compare it with all the values in order to get the maximum value out of the scores array. So previous, previous value, it's going to return. So now if you check if previous value and if previous value is actually greater than the current value, we have just simply go ahead and return the previous value. And otherwise, we don't need any else statements or something. Just like if it didn't return before, all we need to do is just like return the value, because if it's not like the previous value is not defined, or if the value is greater than the previous value, just like simply return the value right here. Just simple if statements, are not really that complicated. Now we got the actual word score, and this is currently a number. And here what we can do is actually go ahead and get the index out of the pretty much the scores array in here. Then we can use this index throughout the class labels array, because they have the same indexes and the same order. Then we can get the class or the label out of this array. So here word adx, I'm gonna use basically so scores.find and value. So if value equals word score, just return me that particular index. And so find index, and this should be an index number. And now last we can go and get the word using class labels and word edx. Pretty simple. Now all we need to do, just like, let me say this is actually the word, and here, there you go. So we got the word. This is actually the spoken and the more predictive word. Of course, if you didn't train your model really great, and you just like, you didn't increase the epochs, or you didn't give it enough data to listen to and train the model with, you're probably going to end up sometimes having some issues once you talk like this. For example, you say hi, sometimes it mistakenly understand that, obviously. So you have to train it right, and you have to give it or feed it the right data in order to be able to, get the right results here. So here's start this distance again, starting, there you go. Create a word, play a song. So for example, I'm gonna say hello, 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 hi, hi, hello, 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 hi, hi. There you go. So the result is actually astonishing in here. It gets the hello word 19 times exactly. Number of times you've talked in right here, hello and hi. So yeah, it does a really good job. So whatever the word you speak actually, and whatever pretty much the class you're going to be saying in here, or how many classes you add, is going to work perfectly the same way in here with this nice visualization. Now we got the words, we got everything we need, we got the infrastructure of actually listening and recognizing the words we need. Now this actually, we need to work more on the core principles of the actual voice assistant. Now what I mean by this, actually for the voice assistant, for example, I say hello. So for this one, it becomes hello, obviously. So we have to use a switch statement or something, and we check, oh, if the word is actually hello, go ahead and use, for example, the browser speech API and say back to the user, good morning, or say, oh, hello Islam, how are you doing today? Hope you're doing great. Something like that, obviously. So we can go ahead and use this, but let's provide a little bit of API that allows us to use this listing or get the word out of this from the app.js. So I'm going to create, so through the start assistant, it's going to have a specific callback in being taken. So on listing, this is actually the callback, and here I'm going to check if on listing. Always before invoking any functions, make sure to check if the function exists, especially on plain JavaScript without any TypeScript or TypeFlow or something. Make sure to check first before invoking. And all listing in here, and all you need to do is just going to give it the actual word spoken in here, the much or the more higher score of the word. So that's basically all you need. Right now, let's keep this word right here. Well, let me just get rid of it because I'm just going to make this abstract API. Yeah, let's just go back into the object.js, and here I'm going to feed it the actual listing. So I'm going to create a new function. Well, this is not going to be like an async function or listing. I'm going to have a word, and yeah, we can go and just console log the word to make sure it works perfectly. So listing, go back here, got the voice assistant, start it over again, and hello, hello, hi, hi, hello, hi. And as you can see, it does work perfectly fine. So now we got the actual word out of the class into this callback. Now we can use this callback and just like, you know, make it feel more like a voice assistant. So in a real world voice assistant, what you do is actually like say hello, then you wait a little bit, like you see on pretty much on the screen of the UI, the voice assistant accepts your speech or your command, then you just like go ahead and process it, and it just gets back to you. So that's basically what happens behind the scenes. So you have to like, you know, you got this place where you have to wait for the processing time and for the response time. So you just like, sometimes you have to stop listening. So for some, like at some point we have to stop this on listing callback. So you can see here we got recognizer, listing, we have to stop it and just like process what the user says, get back to the user and like respond back, then you can continue listening. So that's what I'm trying to say in here at that particular point. So yeah, let's go and do this on the upload.js in here on the listing. So let's go and create another function that allows us to do the processing. I'm going to do like process word. And this is going to be like an async function. So it's going to handle some await functions or stuff like that. So it's going to be just simply an async function right here. And yeah, I'm going to create another variable that allows us to pretty much control whether we need to continue listening or stop listening for a second and respond back to the user. So here I'm going to just like processing word, and it's going to be null, and this is going to hold actually the currently being processed word or not. So for that case, I'm just going to here say if there is a processing word already there, all you need to do is just simply return, just like do not continue execution and just immediately return that. I'm just going to take this a little bit down, and otherwise if there's no word processing or whatsoever, all we need to do is just go and call the process word and pass it the current word. Pretty simple, and make sure of course to set processing word to the new word, otherwise it won't work perfectly as you expected it to be. And yeah, that should do the job perfectly. So here, if for example, let's go and create like a fake method, I'm going to call in here utils.javascript, and this one I'm going to export const some function. I'm going to call this just a wait function. So wait, and this kind of allows us to wait for a specific milliseconds just to have this delay kind of like visualization. So I'm just going to just like return a new promise, and it's going to have resolve, return a set timeout, and resolve if it's actually successfully you know, passed throughout the time, and here just going to feed it through the actual time you provided. It's basically as this. Let's go back in here, and for the processing word, I'm just going to use a wait. I'm going to import that, of course. I'm going to give it, for example, 3 seconds, and we will see if it works or not. So here as well, after waiting finish, what we need is actually set processing word back to null, because oh, we finished processing, so we can just set it back to null and leave every other ones work with it perfectly. So there you go. Here got starting assistant again. Assistant starts. We say good morning, it stops for a second, it say weather, then it stops like for like 3 seconds, there you go, we got the weather again. For example, we say hi, 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 hi. So we get hello, and it stops for the 3 seconds, and it just like, you know, continues listening and so on and so forth. So this one can kind of like create the illusion of, oh, we got the voice assistant, it recognizing our word, or doing searches on the web or something like that, and then you can get back to the actual user. Now that's basically what it is in here. We got the processing word and everything. And for the waiting, I'm just gonna go and git delete for right now. I'm gonna have a switch statement, okay? I'm gonna switch on the word. So here, accepting a word. So for this one, you're gonna tell if what word or what word label we actually currently recognizing or processing. So for example, we got hello. So if you take a look here, we got like hello, we got weather, we got background noise, which we're gonna totally ignore for now. We got good morning, and yeah, so we can have in here, for example, break. We can have another case for like weather, break. Another one, for example, good. Where is that? So let me just copy the exact one so it could be better matched. It doesn't want to copy for some reason. Okay, so good morning, and we got hello, we got good morning. I don't know what others we got, and play me a song, I think. So yeah, you can do play me, or let me just fire that up again. Okay, let's fire that up. Sing me a song. Oh, there you go. We got play a song. Not a play me, but a play a song. And you have to get the exact one. So this is a capital letter and everything. And yeah, there you go. So we're not going to include the background noise because we're just going to totally ignore that. And yeah, so pretty simple. Now for each word, we have to dispatch a single action. And we have, of course, we have to wait for a little bit in order to make it like work and just, get the visualization of waiting. Now for the hello, for example, we're going to use the browser API to respond using voice, of course. And I'm going to use Chrome actually to tell him or tell back the user, and just like use the text to speech API to convert text into actual voice or speech, and say like, oh, hello, good morning, how are you doing today? So for that, I'm going to go back into the voice assistant class. I'm going to create a function in here. So I'm going to just like say speech. It's going to have a text. And for this one, I'm going to use in the API. It's mostly available in Chrome and Firefox, and like right now, everything is being supported. But some like Internet Explorer versions, as we all know, and every time, so are not being supported. So make sure to check that out before deploying it to production. Here I'm going to say like speech, and I'm going to use window speech synthesis. Utterance. So this one, you give it the actual text. So you take a look, it takes a new. Pretty much you give it the text you want to speak, and it just like does the actual processing on it. It converts it to a speech. So you just provide it with the text, and afterwards you use window.speech synthesis. So speech synthesis, and we can do, and make sure just go and use the lowercase letter here and just say speak. So returns, and we can do speech. And there you go. So you do say speech, speak, and you give it the actual speech you give it, and that's basically where it is. So let me just go ahead and use my headphones in here just for listening. So yeah, let's try to call this function right now. I'm gonna use the voice assistant class again. I'm going to say speech, and for example, you can say, hello, Islam, how are you doing today? And obviously, I'm going to use a wait, just like to give it, this illusion of waiting. I'm going to wait for it, for example, like 4 seconds to make it look a little bit better. And yeah, that should do the job perfectly. So let's just go back in here. Site assistant. Hi.
Hello, Ilham. How are you doing today?
There you go. So we got, hopefully you pretty much got that. I don't know if I'm doing something wrong in the recording, but that
Hello, Ilham. How are you doing today?
Yeah, there you go. So I clearly see it just like talks when everybody say hello.
Hello, Ilham. How are you doing today?
So you can, just using the speech API in here, it allows it to pretty much respond and give it like a waiting time in here. You can increase this to make it look a little bit better. So for example, you can just go ahead and use that again. Start the assistant. Hello.
Hello, Ilum. How are you doing today?
Stops a little bit after finishing till we just like, it continues the 6 seconds. I know 6 seconds are quite a lot. So I think 3 seconds will do perfectly the job for us without any issues. So for example, here we said, hello, Ilum, or Islam, for example, because it's weirdly saying my name. How are you doing today? So you can, if it just like says the weather, what you can do, you can go and use some like specific weather API. You grab the weather, then you can say it back to the user, or you can even go ahead and use like the HTML. You can print it out on the HTML. So let's go ahead and try to do that real quick in here. So let's try this service as actually like for getting the weather forecast and using a free API. So yeah, I already got that. I already got the public API key. By the way, I'm going to be changing it later on. So yeah, don't try that. So let's jump right here and let me just call, create a new file called api.js. I'm going to export a couple of functions. So const get weather. I need to give it like city name out of this, or it's going to be a function. Okay. So this is actually the city name. And I'm going to using the fetch API, okay? So weather response. I'm going to do a wait, or pretty much going to fetch. It's going to return a promise, obviously. So I have to make sure to assign this as async. Make sure to wait for it, and I'm going to give it the API with the public API ID. And just going to use ES6 template literals to include the city name at the end. So where is that? Got here. I'm currently just going with London, so I better just go and include the city name there. And it should do the job perfectly right now. For the weather, I'm just going to do like weather response dot JSON. Okay, const JSON response calls await. So weather response.json returns prompt as well, but this one is going to return like a JSON for us with the regular fetch API. Now through the JSON response, what we can include. So if you go back in here, exclusively we got this is actually the JSON objects. We got like location, then we got current. So you have to access current. We do current dot, then we can go ahead and access temperature Celsius. You can use Fahrenheit, but I'm going to use Celsius for now. So temp underscore C, and yeah, so simply just going to make sure to return that in order to return the actual weather. So going back to the app.js in here, we got the actual weather. I can go ahead and just like weather. I can do a wait. I can call get weather as basic as this one. I'm going to provide it with a city. So for example, I'm going to say London. For that sake, obviously here you can just go and do a catch method, because using await, so make sure to do a catch. If any errors occurs, cannot fetch weather. And you can just do error there. Make sure to use the error. I always mistakenly use the log instead of the error method. Yeah, there you go. So you got the weather. Now we can use the speech API there to pretty much say the word, because it's voice assistant, so it almost works as always with speech. Of course, you can add some writing thing. You can just go into the DOM. You can make it write to the actual DOM, but that's not really big deal. So here I'm going to say the weather for today in I'm just gonna do like const location equals London. Okay, there we go. And so let's see. So just temporary literals, and I'm going to do location is, and I'm going to say the actual weather. So I think for this one, does it return degrees? No, it doesn't return degrees. But I can go ahead and make this degrees, so you say like 13 Celsius degrees or something. So let's try that and see how it looks like. We'll also make sure to include await for 3 seconds. All right, so there you go. Let's jump back into our work in here. So let's start the assistant. How's the weather, please? How is the weather?
Hello, Ilum. How are you doing today? Hello, Ilum. How are you doing today? The weather for today in London is 11 degrees.
There you go. So
the weather for today in London is 11 degrees.
There you go. It's just like I keep talking, it just like keeps getting it. But yeah, it does work pretty much fine. So it just goes to the API, gets the weather, and pretty much gets back to you with the weather, like 11 degrees. If you take a look on the API in here, it's indeed in London, it's 11 degrees. And you can give it a different location, like Berlin or something, and it will work pretty much absolutely fine. So voila, we got an absolutely amazing voice assistant that does a job perfectly. You can make it do other things, like you say, for example, good morning, and you make it say something. And let's try to do voice assistant. So say speech, for example, say, good morning, Islam, hope you slept well. And then if, for example, I'm just going to give it a couple of spaces, then, or like, hope you slept well, and you just like give it the schedule for today. So for today, you have, for today's schedule, you have a meeting at 10 a.m. with your manager or something. Okay, just you say good morning, just give you your schedule thingy, and as always, just make that goes right there. So there you go. Let's start this.
Good morning, Ilum. Hope you slept well. For today's schedule, you have a meeting at 10 a.m. with your manager.
Yeah.
Good morning, Ilum. Hope you slept well. For today's schedule, you have a meeting at 10 a.m. with your manager.
Okay, I didn't.
Hello,
even
Ilum.
have to,
How are you doing today?
Sometimes you could get
the weather for
bit.
today in London is 11 degrees.
Yeah, as you talk, even you don't talk like precise words. Sometimes you just like picks it up because voice assistant, like real world voice assistants, are made with specific microphones that are made for picking up only the voice they need. Also with a really trained and huge neural network that knows what it's doing. So don't expect this is actually going to be like the best you're going to be creating. But in the fact you actually be able to create like a voice assistant in JavaScript in real time working in a browser, it's absolutely amazing. I'm just like super proud I've been able to make this kind of video tutorial for you guys, and hope you actually guys watched it and enjoyed it, every aspect of it. And the last one in here, just gonna complete it real quick. Let's try to sing a song. All right, so for singing a song, well, let's go ahead and see. Okay, Christmas. Or let's try bed song, okay? I don't know. Let's we got a lot of searches there. I don't know. Bed song lyrics. We are friends, a sleeping bag, splitting the hot hates. We have a filthy pillow. Exhibit A, Exhibit 2. It won't probably work as we want it to be, so I'm pretty sure this won't take it. So let's try a couple of like sentences. Let's copy this, go voice assistant real quick, say speech, and I'm gonna go through this real quick. So I'm gonna also use voice assistant again, say speech. Let's copy another sentence real quick, paste it there. Let's copy a third one. We laughed at people are drinking. Or just like this is the sentence. Alright, so voice assistant. There we go. And let's see if that actually does make any sense. I'm pretty sure it won't because it's not specified, like the speech API of the browser is not made for actually telling words or singing songs, obviously, but at some point it might do something. Sing me a song.
We are friends in a sleeping bag splitting the heat. We have one filthy pillow to share and your lips are in my hair. Someone upstairs has a rat that we laughed at. We are friends in a sleeping bag splitting the heat.
And there you go. Sometimes it just like becomes super annoying, just like he keeps going without stopping, I know. So yeah, you might go ahead and tweak that a little bit and make it look a little bit better with the logic and everything. But I hope you guys, enjoyed the video as always, and I hope you actually liked this video tutorial on voice recognition and voice assistants and Korean real world voice assistant clone, obviously. So yeah, I hope you guys have enjoyed the video tutorial. If you just indeed go on to like clone the repository here and try, for example, go ahead and add some little bits of it, or just like add the new features, make it do a little bit better, retrain the model and re-upload, or try to do like a pull request. Yeah, that will be absolutely amazing. I'll be very happy to check your repositories or your clones or your PRs. And yeah, we can create some like a basic voice assistant JavaScript and we can all contribute to it. Why not? So as I said before, I hope you guys have enjoyed the video tutorials. Hopefully you've enjoyed it. Hopefully you like this kind of videos. And if you do, make sure to subscribe and push the like button. It's gonna kind of like help me a lot. And yeah, without further ado, that I say, I'll catch you all guys in the next ones.